Hello guys, this is CodeNCode, and in this lecture we are going to learn how we can solve the subtree sum queries with node update using segment tree or fan tree. Okay, so the problem statement is simple. We have already discussed the type of problem you can solve using range query techniques in the previous lecture. That is lecture 10th of queries on tree course. Okay, so I highly recommend you to go through that lecture first. So this is one of the problems that we can solve, the first example that we discussed in the previous lecture. So the problem was, you are given a tree and each node is having certain value, and you are given q queries of two types. First, you have to change the value of node v to certain other value, right, say x, and then find the sum of values in the subtree of node v. This is the problem statement. So we'll be solving using fan tree, or you can solve this problem using fan tree or segment tree, depends upon what you want to go with. I'll highly recommend you to go with fan tree because that uses less space and is faster, not asymptotically but the constant factor. So since we know that we are going to apply either fan tree or segment tree, which can be only applied to an array or a linear data structure, right? So first of all, we have to convert this tree, which is a non-linear data structure, to a linear data structure. That is why we'll use the technique Euler-Tor technique, basically tree flattening. So it is a fancy name given to saving the order. I mean, we can't even say fancy word because this guy must have worked really hard to come up with this technique, so my bad. This is a technique in which you apply only simple DFS and then record the ordering of node visited. So I have already covered Euler-Tor technique in detail, so I'm not going that much detail into it. So you start with the root. So for example, it was node 1, then so at position you have node 1. Okay, then you went to node 5, 2, 4, 3 and 6 in the same order. So that's why we have this array. Okay, now you have flattened the tree and now you have an array. Now what is the what is the properties of this flattened tree array? See here, for each node, its subtree actually becomes a subarray in this array. Okay, for example, for node 4, you see 4 and 3, right? These two nodes are subtree of node 4, and you can see it is appearing as a subarray. For example, node 2, so 2, 4, 3 and 6 should appear as subarray, right, starting from node 2 itself. So starting from node 2, all of these are appearing as a subarray. So now if you want to find out the sum, you can actually apply the subarray query, right? That's why this is very helpful. There's one more version of it where we store the starting as well as ending time, or basically the time when you enter and the time that you leave. That is another technique. We'll use that as well. Both of them can be used to solve different kind of queries. So now before I explain further, let me go ahead and tell you one more thing. Unacademy and CodeChef are conducting classes that are open to all. That means they are completely free. All you have to do is verify your number and put in my code to get access to all of the free lectures. For those who want to access this on mobile, you can download Unacademy mobile app. So why you should take these classes, right? First of all, these classes are being taken by the guys who themselves have cracked the interview for the companies like Google, Microsoft, etc. Either they are ESM ICPC World Finalists or 7-star at CodeChef or problem setters themselves. So you will be learning from the best the industry have to offer, of course, apart from me. More than 60 hours of content is being added every week. All you have to do is verify your number and put in my code to access all of them. Okay. Link to access all of the free lectures I'll be providing in the description of the video. But if you want to have a structured learning approach where you know exactly how much you will be learning and practicing on a weekly basis, you can become a paid subscriber and get access to all of the currently running and past batches courses. Link of upcoming batches in the description of the video. So let's head back to our lecture. So after we apply Euler-Tor technique, now we have the flattened array. So first of all, we are not going to build this array. We won't need it at all. So we only need these two arrays. In time, for each node, we'll note the time when we reach that node. Okay, that's called the in time for. So we'll only for each node store its in time, and also we'll save the values of the nodes in this array, and we'll apply segment tree. We'll build segment tree on this array. Okay, so first I reach node 1, so at position 1 I must have value 3 because yeah, right, this is the place where node 1 exists. Then I went to node 5, so at position 2 I must have value of node 5, which is 2. Yeah, so here you can see this is storing for each node its time when we entered it. So at for node 1 we entered node 1 in DFS at time 1, right? That's why at position 1 I am having 1. Node 2 I entered at time 3. How? See, from here I went to here, so node 5 is having time 2, so node 5 is having time 2. Node 2 is having time 5. Node 2 is having, sorry, node 2 is having time 3. This is the value I got confused. So node 2 entered at time 3, right? Because 1 2 then 3. So node 2 is having time 3. So this is the in time. I have already covered in time and out time in graph theory part 1 series. So if you have no idea, you can go ahead and check that first. Okay, so these are all of the in time, and as we traverse this DFS, as we traverse these nodes, we will keep storing their value in the array. So at time 1, so at position 1 I'll have 3, at position 2 I'll have 2, at position 3 I'll have 5, and at position 4 I'll have 6, then 1, then 1. So here you see this is the array that we've built. Okay, the value array, which correspond to the value of node which were ordered in the same order. Okay, which were traversed in the same order. After that we'll apply segment tree on this. If I have to find say subtree sum of node 2, so what I'll do, yeah, we'll also store subtree size, because that will help us determine the range. So see, for node 2 I want to find out the subtree sum, right? So in this array what would be the range for node 2, right? So the we already know the subtree exists as a sub array. So what is the starting and the ending point of the sub array for certain node, right? So first of all, the starting position is the in time of that node. So for node 2 the in time is 3, so starting position is this. Here you can see, and ending position is starting position plus number of starting from this position you traverse as many elements as there are in the subtree of node 2. How many elements are there in the subtree of node 2? There are like 4 elements. So starting from this, the first 4 elements are the subtree of this. So take the sum of these values, which is 6 5 11 and 13, and this is this. Okay, so after preparing those values, after preparing in value as well as the array, we will build segment tree on that array. After that we are left with two types of query. First is point update. So of course, suppose I wanted to update the value of node 3 to be 2, right? Currently it is 1, so I want to update the value of node 3 to be 2. So what point I should update in the array, value array? Well, you might have guessed, the in time of node 2, sorry, node 3. So in time of node 3 is 5, so I'll update this position. So it would become, here you see, it becomes 2, right? All you have to do is fire a update query in the segment tree or fanfic tree. Position would be in time of the current node and value would be new value passed. Okay, and after that we are going for, right, range sum. Range sum is easy, as I have already explained. Range would be starting time, starting and end range would be in time of node, and in time of node plus subtree size minus 1, right? In time of node 2, in time of node 2 is 3, so starting from position 3, subtree size is 4, 3 plus 4 is 7, minus 1 6, so 3 to 6, starting from 3 4 5 6, right? So this way you will be able to find out the range sum. So all you have to do is point update and range sum. Before that we have to flatten the tree. You can use simple DFS for that. We will also calculate, of course, the in time and subtree size. So if you are worried about the implementation and you are thinking, first of all, I highly advise you guys to go ahead and try it yourself. Okay, otherwise if you are worried about how, but whether you will be able to update I mean implement it or not, don't worry. Soon I'll be uploading the solution of a problem, I guess, subtree queries from CSCS tree algorithm. Okay, that problem can be solved using this exact way. Okay, so I'll be uploading the tutorial for that, so that after learning this technique you can apply your solution to that. I'll be posting the link of that problem in the description of the video. So if you want to apply this technique on your own to solve that problem, that is very good, right? You'll be learning a lot if you are going to solve that problem yourself. Otherwise, if you are not able to solve, just at least try it once. If you are not able to solve it, don't worry, I'll be providing the tutorial soon, right? So but if you want to try it yourself, that is really good. You will be learning a lot. So yeah, this was all for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.